All right, so let's take a look at trinomial factoring again. So these trinomial factorings are a little bit more difficult than the ones that we were doing last week. We have to use what I like to refer to as smart guesses. So some of your options, there's going to be a lot of options, so we're going to try to help you figure out how to narrow that down a little bit faster than doing just purely guess and check. So number one, we got a trinomial that starts with 4x squared. There is not a GCF there between the 4, the 11, and the 3. So you have to start thinking to yourself, okay, 4x squared, there's two ways we can get a 4x squared. Either 4x times 1x or 2x times 2x. Those are our two options. So we're going to end up picking one of those. But before I actually go ahead and just pick one and try it, I'm going to take a look at the other stuff that we have here. The other one that plays a big part in this is the 3. So remember, we have to come up with what multiplies to give us a 3. Only options are a 1 and a 3. Because I want this 11 right here in the middle, that tells me I'm probably not going to want to use 2x and 2x. Because I would do the 2x times the 3 when I do my little smile, big smile. That would only get me a 6. Not going to be quite high enough. So I'm actually going to try this one. So I'm going to try 4x and 1x. And again, because I want to get this 11 in the middle, I'm actually going to put my 3 over there. So remember, those two terms end up being multiplied together. So when I do my 4x times my 3, this gives me a 12x. And because I want that 11 to be positive, that tells me my 12x should probably be positive also. So I'm going to make it a plus 3. And then the other term is a 1, and it's going to be negative because it was a negative 3. So one of them has to be a negative in the long run. And so then when I multiply those two together, I get my negative 1x. So negative 1x plus 12x, there's our 11. So 4x minus 1 times x plus 3. So let's try it again for this next one. Number 2 has smaller options, less options than number 1 did. So for 2x squared, only way we can multiply to get a 2x squared. That would be 2x times 1x. So then again, looking at our last term, that 3, what multiplies to give us a 3? 3 and 1. Am I going to want to put my 3 here? No, because that's going to end up being multiplied by the 2, which would give me a 6, which is already bigger than what our middle term is. So I'm going to want to put my 3 here, my 1 here, and both of our signs are going to be positive. So again, when you're checking, and you can do this check in your head, you don't have to write this on your paper, we end up with a 3x and a 2x, so when we add them, there's our 5. Looking at our third one there, 5x squared. Again, not many options to get us a 5x squared. That's going to be 5x and then the 1x. What multiplies to give us a 7? 7 and 1, not many options. Which number am I going to want to put with the 5? The 7. Because if I put the 7 over here in the other set of parentheses, it would get multiplied by the 5, making it a 35. We don't want a 35. We just simply wanted a negative 2. So which one's going to be our negative? 7. And then a plus 1 there. All right, so let's have you take a minute. Go ahead and try those bottom 3 on your own. And then that last one there should be 3x plus 8 and then x minus 4. All right. So then a quick little overview again of factoring completely. Factoring completely is one of those unwritten rules of math. You always have to factor completely, but they will not always tell you that you need to factor completely. It's kind of like simplifying. You always need to simplify, but they're not always going to remind you that you need to simplify. So with our factoring completely, we always look for first a GCF. That is always the way we start factoring. GCF, look to see if the GCF is there. If it is, take it out. Sometimes it's not there, sometimes it is. And then it kind of branches off into 2 ones after that. If it's got 2 terms, you're going to look to see if it's a dots factoring, which it may be. If it's got 3 terms, then you're going to look to see if you can factor using the trinomial method, so basically the guess and check. So GCF, and then you got to figure out, is it 2 or 3 terms? So taking a look at my example over here, I have negative 2x squared plus 5x minus 2. Is there a GCF between those three terms? Negative 1. So I'm going to factor out my negative 1. All really that negative 1 does is it just changes all of your signs. So now your 2x squared is positive, negative 5x plus 2. We've always got to factor out a negative if that first term is negative. So then we ask ourselves, is there two terms? No. So we're not going to factor using dots. There's not two terms left. There are, however, three terms left, so we will use trinomial method. So kind of like we were doing up above, 2x squared. What multiplies to give us 2x squared? No, 2x and 1x. And then we've got another 2 at the end, so where should I put my 1 and where should I put my 2? Yeah, 2 goes with the x, so then the 1 goes there, and our signs are going to be what? Both negative. So there we go. There's our final answer. That negative 1 has to be there. That is part of your final answer. If it's not there, then it's going to get marked wrong, so make sure it stays there. So on the back here, we just have some examples practicing our factoring completely, so we're going to be factoring more than once here. So that first one, number 7, do we have a GCF? Yes, A. So I factor out my A. I'm left with x squared minus 1. So we look inside the parentheses. Can we factor x squared minus 1 again? Yes. A lot of people forget about that one because it's such a basic one. But yes, x squared minus 1 is a dots problem. So that factors into x minus 1 times x plus 1. So then can we factor any of those again? No, that one's done now. All right, number 8, do we have a GCF? Yes, what is it? 4. So I take out my 4. I'm left with x squared minus x minus 6. So the trinomial, when you're trying to check to see if it's factorable, you got to look at that last number. Is there something that multiplies to 6 but will add to give me a 1 in the middle? 3 and 2. Which one will be our negative? The 3. Very good. So x minus 3 and then x plus 2. Nine, is there a GCF? Right, this one's going to be a dots problem. There is no GCF here. That will happen from time to time. You're not always guaranteed a GCF. So the square root of the first term gives me 4a squared. Square root of my second term gives me b squared. One's plus, one's minus. Can we factor either of those again? Yep. Yeah, the first one here. This is another dots factor. Those are both perfect squares with a subtraction sign. So 2a minus b, 2a plus b. From my original factoring, can I factor that second one again? No. So we just got to bring that one down. So 4a squared plus b squared. All right, take a minute. Try those last two, 10 and 11. See if you can factor those on your own. Look for first GCF, then dots 2 terms, trinomial 3 term. There we go for that last one, x squared plus 7, and then x minus 2, x plus 2. So again, always have to do that. That's the order, GCF, then look to see if you can factor any further. These next two, same process. You're still going to look for GCF first, and then you're going to factor again if you can. It's just if your leading coefficient is negative, you always have to factor out a negative. So looking at number 12, we start with that negative 3x squared. So let's look first. What is our GCF going to be? Negative 3. So then we got x squared plus 2x plus 1. So is there something that multiplies to 1, adds to 2? 1. 1 times 1. So x plus 1, x plus 1. Now what's our other way of being able to write that? That is a perfectly right answer, but there is another way that you could see it. Megan? Yes. So negative 3 and then x plus 1 squared. So just keep in mind, those two are the same exact thing, just a different way of writing it. 13, what's our GCF? Negative 1, because it technically looks like it's nothing, but you got that negative in front of the x squared, and we can't have that, so we got to take out a negative 1. So again, all that does is it changes their signs, so everything's positive now. So what multiplies to 8 adds to 9? 8 and 1. There we go. So then down here we have a new type of factoring. Has anybody heard of factoring by grouping before? No. So factoring by grouping works if you have an even number of terms, so 4, 6, 8. Doesn't work if you got 5 or 7. So if we look at our 4 terms that we have here, is there a GCF amongst all 4 terms? No. So there's really not too much that we can do. So what we end up doing is we group the first 2 terms, and then we group the last 2 terms. Some teachers refer to this as a flower box because it looks like I just drew 2 flower boxes where the numbers are my flowers. So now taking a look at my groups, if I look at my first grouping now, is there a GCF within those 2? X squared. So I factor those 2 terms just as if it was only those 2 terms, so x squared and then 2x minus 3. Looking at our last 2, is there GCF within those? 4. And again, my leading term here in this group is negative, so I'm going to take out a negative 4. And then that gives me 2x minus 3. So because my 2 parentheses match, that means we are doing the process correctly. They're both at 2x minus 3. So then this goes back to what we were doing last time. Sometimes your GCF is a binomial. Our GCF here is this binomial, 2x minus 3. So I pull my binomial GCF out. Remember, we go back and divide by it, so what's left? X squared minus 4. Which we can factor x squared minus 4 again into x minus 2, x plus 2. And then that 2x minus 3 still has to be there. So let's take a look at our next example. So again, is there a GCF for all 4 terms? Mm-mm. So I'm going to group the first 2, and then I'm going to group the last 2. What's our GCF between those first 2? by squared. So when I go back and divide by that by squared, we're left with a b plus 1. GCF for the second second group of terms are positive 3. And then again, once I divide by that 3, I got a b plus 1 again, so that means we're doing it correctly because our parentheses match. So we factor out our binomial GCF. So when I do that, I'm left with by squared plus 3. And then are either of those factorable again? No. So that one's done. All right, on the top of the next page, there's 4 more examples. I want you to try those 4 examples on your own. Group the first 2, group the second 2, find their GCFs. There you go, take a look. That's what you should have ended up with for these. This one over here, the top one on the right, a lot of people thought they got it wrong because, you know, you could actually subtract that and get a 3. That's not wrong, that's just the way that problem ended up happening. So. we will be practicing this. Factoring by grouping we'll be using a lot. All right, and then my last box down here. I like to call it funky factoring because it looks like factoring, but then people second guess it and they think it's not actually factoring, but it really is factoring. So with the funky factoring, I'm going to teach you some strategies that you can use when you see problems that are a little bit more complex like this. Doesn't mean you have to. There's way more than one way to do all of these problems. I'm just going to try to teach you a little trick for it. So if we look at the first box here, we have x plus 5 squared minus 4 times x plus 5. Now because the stuff in both of those parentheses are the same, I can replace it with just a single variable for the time being. I don't want to use x because that's part of the problem. But I could, for example, use the letter a to represent x plus 5. So I can substitute an a in instead of the x plus 5, so that gives me a squared minus 4a. Now it's a little bit easier of a problem. What kind of factoring would we end up using? They both have what? A, GCF. So we would factor out an a, so we would have a times a minus 4. Can we do any more factoring with that? Nope. So what we're going to do then is just plug back in the x plus 5 for your a. So this a would just get replaced back with the x plus 5. That part's good. This other parenthesis would be x plus 5 from that a. And then minus a 4, which we could actually subtract the 5 and the 4, which would give us a what? 1. So x plus 5 times x plus 1. Now I realize that sometimes that gets confusing with the whole substitution thing, but just to kind of give you an idea, the other way you would end up doing this is you would start off with x plus 5, writing it out twice, multiplying everything out, combining your like terms, distributing your 4, combining it with your like terms, and then trying to factor again. So if you can see this and do the little substitution, it's going to make things a lot faster for you. So let's look at the second one there. 4 times a plus 1 squared plus 12 times a plus 1 times negative 40. So again, the stuff in the parentheses is the same, so I'm just going to replace it with a different letter instead of having to write the parentheses. I'm going to use x this time because there isn't an x in the parentheses. I can't use that same letter. Now it's a little bit easier for us to factor. Do we have a GCF? 4. So that gives us 4, and then x squared plus 3x minus 10. What would that factor into next? X plus 5, and then x minus 2. So again, because we substituted to try to make it a little bit simpler, we just have to plug back in what we originally started with. So for my x, I got to put in an a plus 1. So instead of x plus 5, it's a plus 1 plus 5. And then instead of x minus 2, it's a plus 1 minus 2. So then we just got to combine our numbers. So a plus 6, a minus 1. So looking at our third example there, I see 4 terms, so automatically my head thinks to myself, okay, we have to do factor by grouping since it's 4 terms. But if I do my grouping, do I have anything in common really? Like my second group has an x to it, but then it wouldn't match from my first group. So sometimes in your grouping, what you might have to do is you might have to rearrange some things. So for example, x squared, I'll put it with the last term. I could have put it with the cx. It really doesn't matter. You're still going to end up with the same answer in the long run. You just want to find a term that has something in common with it. So I'm going to rearrange this so it's x squared plus ax right next to each other. And then my minus ac and then minus my cx. So now when I do my groups, I actually have some things in common. First group's GCF would be an x. So I would get x times x plus a. Second group's GCF would be what? Negative c. Now my parentheses aren't identical, but are they the same? Yeah, because remember, commutative property, we can change those two things around, so really they are the same. So our final answer would be x plus a times x minus c. So how about for that fourth one over here? Again, 4 terms. So automatically I'm thinking grouping, but when I do my groupings, do we have GCFs? I mean, yeah, but it doesn't really work out in our favor. If I rearrange it, is it really going to work it out any better? No. So let's say I look at just these first 3 terms. Does anybody know what those first 3 terms there make up? A trinomial, a very specific trinomial. This is what we call a perfect square trinomial. Those first 3 terms make up what we call a perfect square trinomial. It's a very specific one that helps us out a lot. So if we were to factor those first 3 terms, it would end up factoring into a plus b times a plus b, which how do we rewrite a plus b times a plus b? A plus b squared. A perfect square trinomial always gets factored into one thing squared. That's why it's a perfect square trinomial. So if I rewrite those first 3 terms as a plus b squared and then put my minus 16, do we have dots factoring now? Yeah. Where my a plus b, like if that were an x squared minus 16, we can factor that. That's going to be a dots factoring. So it would be a plus b, my first term, minus 4. And then a plus b plus 4. Just kind of like if we had an x squared, it would be x and x. A plus b squared would be a plus b and a plus b. And then the minus 4 plus 4. So looking at our last one, how many terms do we have? 6. So you could group these in groups of 3s and make 2 groupings if you wanted to. This one doesn't work out well if you do that. This one actually works out best if you go in groups of 2. And I always have kids ask me, well, how do you know which kind of grouping to do? I always say it's easiest. Do groups of 2. That's generally going to work out in your favor. So looking at my first grouping, what's our GCF? K squared. And then we got k squared minus 4 is in the parentheses. Second group, what's our GCF? 8k. And then I would have k squared minus 4. If you're doing this and your second parenthesis doesn't match your first one, I would stop right there because that's like the main thing is those parentheses have to match each other. If they're not, then that means you might have to rearrange things. And then our third group, what's our GCF? 12. And then k squared minus 4. So all 3 parentheses match. We are good to go. They need to. So we'll pull out the GCF, which is the k squared minus 4. This time we end up being left with a trinomial, which is what I would expect to have happen since there were 3 groupings. I would expect a trinomial there. If I had 4 groupings, I would expect 4 in there. So now we just have to see if we can factor further. K squared minus 4, can we factor that again? Yes. k minus 2, k plus 2. Can we factor the trinomial? What multiplies to 12 adds to 8? 6 and 2. So again, that is a perfectly acceptable answer, but what is another way that we could write that? Yeah. K plus 2 squared, then your k minus 2, k plus 6. Especially if this is like, for example, multiple choice on your Regents exam, they will rewrite it. So you just have to remember that these two things are the same.